morning to all. Today our topic is effects of electric current. So effects of electric current is three important effects. One is heating effect. And second one is magnetic effect. And third one is chemical effect. Effects of electric current. So three effects are important role in this topic: heating effect, magnetic effect, and chemical effect. So what is the heating effect? Heating effect of electric current is nothing but electric energy convert to heat energy. Example: water heater, water heater and ion, electric ion is a good example of heating effect of electric current. Magnetic effect. Electric energy convert to magnet, and means electric current flows through the conductor. The magnetic field should be developed around the conductor. This phenomenon is called as magnetic effect. And third one is chemical effect. Electric energy is convert to chemical energy. Good example: cells. Well in lower section, primary cell and secondary cell. So chemical effect. Now we are discussing about the topic name is heating effect of electric current. So heating effect of electric current is nothing but when current flows through the conductor, heat energy is delivered from the conductor or resistor, dissipated form of heat energy. Is called as phenomenon called as heating effect of electric current, or called Joule's law of heating or thermoelectric effect. For example, I want to take one resistor. Flow of current is I. The resistance is R. Applied voltage is V. Positive, negative, applied voltage is V. Flow of current is I. You know well, the flow of charge is Q. Net charge is Q. According to definition of electric current, I is equal to rate of flow of charge is called as electric current. So Q divided by T. So Q is equal to IT, current into time. In resistor, flow of current is I, applied voltage is V, in flow of charge is Q, time of T. So definitions of electric current: I is equal to Q divided by T, Q is equal to IT. So you know well, potential difference. Potential and potential difference. Potential difference is nothing but the work is done. And unit positive charge flows from one point to another. V is equal to work done divided by charge. So work done, which is equal to VQ. So charge is equal to Q is equal to I into 2 according to definitions of electric current. Definitions of potential difference: work is done, the unit positive charge flows from one point to another. You know well, V is equal to work done divided by charge. The work done is nothing but almost equal to potential difference when move to unit positive charge from one point to another. So work done, which is equal to V into Q. So work done, which is equal to V into Q. V into Q. Q is equal to nothing but I into T. So this work done, which is equal to VIT. This is the equation number 1. When electric current flows through the conductor or resistance, heat energy is delivered from the resistor or dissipated in the form of heat energy. This is called as heating effect of electric current. This phenomenon is called as heating effect of electric current, or Joule's law of heating from the derived Joule. That's why it's called as Joule's law of heating. See, V is equal to work done divided by charge. Q is equal to I into T. So work done, which is equal to VIT. So where is comes from this heat? Which means the loss of energy, flow of charges. The loss of energy is converted to form of heat energy. So here electric energy is converted to form of heat energy H. Where it comes from this heat energy? The work done of charges is converted to form of heat energy. Here this work done is converted to form of heat. H is equal to VIT. This is basic equation. So heat energy, where it comes from this, the work done of flow of charge is converted to form of heat. So H is equal to VIT. Here heat energy H is equal to VIT. You know well, according to Ohm's law, V is equal to IR, I is equal to V by R. So apply equation. This is equation number 2. So heat energy H is equal to VIT. So according to Ohm's law, V is equal to IR into I into T. So H is equal to I square RT. Equation number 3. This is a Joule's law of heating. What's a Joule's law? The dissipated heat energy is directly proportional to square of current, and heat energy is directly proportional to resistance, and heat energy is directly proportional to time. It is a basic equation, heating effect of electric current. See, heat energy is directly proportional to square of current when resistance and time is constant. It is very important. Heat energy is directly proportional to resistance when current and time is constant. Heat energy is directly proportional to time, current and resistance is constant. It is a basic equation. So H is directly proportional to I square, H is directly proportional to resistance, H is directly proportional to time. This is current law, this is resistance law, this is time law. So heat energy is directly proportional to square of current, heat energy is directly proportional to resistance, heat energy is directly proportional to time. This is Joule's law of heating. It's a very important one. Heat energy is equal to I square RT. I square RT. Heat energy directly proportional to square of current, resistance, time constant. Heat energy is directly proportional to resistance, current and time is constant. Heat energy is directly proportional to time, and current and resistance constant. It's very important. Heat energy directly proportional to square of current. Remaining two factor is constant. Heat energy is directly proportional to resistance. Remaining two factor is constant. Heat energy is directly proportional to time. Remaining two factors constant. This is Joule's law of heating. So heat energy H is equal to VIT. H is equal to I square RT. This is equation number 1. This is equation number 2. So another one is heat energy H is equal to VIT. H is equal to, according to Ohm's law, you know well, V is equal to IR, I is equal to V by R. So V into I is equal to V divided by R, V divided by R into T. So heat energy H is equal to V into V, V square divided by R into T. This is another one form of heating effect of electric current. So H is equal to VIT, first equation, H is equal to I square RT, second equation, third equation, H is equal to V square divided by R into T. It's a controversy here, two equations. Equation number 2 and 3 is a controversy equation. See, heat energy is directly proportional to resistance from equation 2. Heat energy is inversely proportional to resistance, equation number 3. It is a very important, here very important role. H is directly proportional to resistance when current is constant. See, an important role. H is directly proportional to resistance. Heat energy is directly proportional to resistance when current is constant. When current is constant means we are using H is equal to I square RT. Here heat energy is inversely proportional to resistance when potential is constant. It is an important role. H inversely proportional to R. Heat energy inversely proportional to resistance. Potential is constant. Heat energy is directly proportional to resistance. Current is constant. It is a very important. You know well, according to resistors connected in series, connected in parallel. If resistance connected in series, current constant, you know well. So heat energy is directly proportional to resistance. Resistance in connected in parallel, potential is constant, so heat energy is inversely proportional to resistance. So the equation current constant means we are using H is equal to I square RT. Potential constant means we are using H is equal to V square by R into T. In same phenomena, you know well, H is equal to I square R into T. So H divided by T is equal to I square R. H divided by T, you know well, energy divided by time. Rate of flow of electric energy is called as power. So P is equal to I square R. See, heat energy divided by time, which is equal to dissipated power. P is equal to I square R. You know well, P is equal to VI. According to Ohm's law, V is equal to IR into I. So P is equal to I square R. Another one, P is equal to VI. So P is equal to V into I is equal to V divided by R. So P is equal to V square divided by R. Same phenomena. P is equal to I square R. Power is directly proportional to resistance when current is constant. Power is inversely proportional to resistance when voltage is constant. Same phenomena. So P is equal to I square R. So H is equal to I square RT and H is equal to V square divided by R into T. So two equations are important role in heating effect of electric current. So example 2.27. Find the heat energy produced in a resistance of 10 ohms when 5 ampere current flows through it for 5 minutes. What is data? First of all, write data. Resistance R value is equal to 10 ohm, I is equal to 5 ampere, time t is equal to 5 minutes, which is equal to 5 into 1 minute equal no well 60 seconds, which is equal to 300 seconds time. So when find the heat energy produced in the resistance of, see, resistance R, flow of current is I, applied voltage, potential difference is V, resistance value. I want to calculate the time of t is equal to 5 minutes to measure the heat energy dissipated from the resistance. So to find the heat energy produced in a resistance, you know well, H is equal to I square R into T. H heat energy, H is equal to, what is I value? I 5 ampere. So 5 square into resistance value is 10 ohm into time is 300 seconds. Your minute value convert to seconds. So 300 seconds. So H is equal to 25 into 300 into 10. So 3000 joule, which means H is equal to I square RT joule. So H is equal to 3 into 25, 75,000 joule. So heat energy is equal to 75,000 joule, 1 kilojoule. So 75 kilojoule. Direct equations. You know well, I value, V value, and R value. So I want to calculate power value. P is equal to V into I. So V into I is the get power, dissipated power values, and H is equal to I square RT, or H is equal to V square by RT. Any one of the equations you use, we use this. H is equal to I square RT. So for heat energy dissipated from the or produced in the resistance is 75 kilojoule. So another one example. When a current of 3 ampere is passed through a piece of time, the heat produced in 8000 joule. If the current is doubled by keeping all other quantities are constant, remaining quantities are constant. If current is doubled, what happens to heat energy? You know well, according to Joule's law of heating, H is equal to I square RT. I square RT. Heat energy is directly proportional to square of current. Heat energy is directly proportional to resistance. Heat energy is directly proportional to time. Here, first of all, 3 ampere current is passed through the piece of wire or resistance. Time of heat produced in 8000 joule. If the current is doubled by keeping all other quantities are constant. All other quantities are constant. What happens if current is doubled? Heat energy is directly proportional to square of current. First one, H1 is equal to I square RT. I1 square RT. So, here varied content, current and heat. Remaining quantities are constant. So, R and time, resistance and time is constant. H2 is equal to I2 square RT. This is equation number 1, this is equation number 2. Equation 1 divided by 2. H1 divided by H2 is equal to I1 square divided by I2 square. So remaining factors constant. Divide value remaining characters. I mean both R and T is constant, that's why cancel. So H1 divided by H2 is equal to I1 square divided by I2 square. So if the current is doubled, we mean second current I2 is equal to 2 times of I1. Current is double, so that's why I2 is equal to I1 whole square. To I1 whole square. So H1 divided by H2 is equal to I1 square divided by 2 I1 whole square. So 4 I1 square. So I1 square cancel. So H1 divided by H2 is equal to 1 divided by 4. I want to calculate to H2. H2 is equal to 4 times of H1. If current is double, heat energy increased in 4 times. So H2 is equal to 4 into H1 value is 8000. 8000 joule. So 32,000 joule. H2 is to increase it 4 times. So H2 is equal to 32 kilojoule. If current is, heat energy is directly proportional to square of current. So current is double, heat energy is increased in 4 times. Another one example, if two resistance R1 and resistance R2, they are connected in series, and R1 and R2 they are connected in parallel. What are heat ratio? For example, I want to take simply R1 is equal to 1 ohm, R2 is equal to 2 ohm. They are connected first in series. This is R1, this is R2, this value is 1 ohm, this is 2 ohm, flow of current is I. According to Joule's law of heating, H is equal to I square RT. Here they are connected in series, the flow of current is same. You know well, I current, this is also I current. If resistance connected in series, current same. If resistance connected in parallel, potential is same. You know well. So H1 is equal to I square R1T. You know well, because of R1, flow of current and time is constant. H2, heat energy dissipated in form of second resistance R2. I square, because of same amount of current flows to the R2 resistance. That's why I square R2T. So this is equation number 1, this is equation number 2. So divided equation H1 divided by H2 is equal to ITT, I cancel. So R1 divided by R2. So H1 divided by H2 is equal to 1 divided by 2. So H1 is H2 is equal to 1:2. Because of they are connected in series. Same resistors connected in parallel, what happens? This is R1, 1 ohm. This is R2 is equal to 2 ohm. Connected in parallel. So voltage is same, you know well. So H is equal to V square divided by R into T. This is a common equation. When connected in parallel, heat is inversely proportional to resistance. So H1 is equal to V square divided by R1 into T. H2 is equal to V square divided by R2 into T. Because of they are connected in parallel, potential same. Applied voltage is V, here V value, this is also V value. But current, flow of current is divided. This is I1, this is I2. You know well. So H1 is equal to V square divided by R1 into T. H2 is equal to V square divided by R2 into T. So I want to calculate this heat ratio. H1 divided by H2 is equal to V square divided by R1 into T into R2 divided by V square T. So V square T cancel. This is R2 square divided by, R2 divided by R1. So H1 divided by H2 is equal to R2 divided by R1. This means 2 by 1. So H2 is equal to 2:1. When the connected in series, 1:2 answer. When connected in parallel, heat ratio is 2:1. This is an important phenomenon because of H is equal to I square RT. When connected in series, when connected in parallel, H is equal to V square divided by R into T. Heat energy is directly proportional to resistance. When current is constant, heat energy is inversely proportional to resistance when voltage is constant. Heating, and next one is the applications of Joule's law of heating. It is a very important role. Electric ion, electric heater, electric fuse. This is the main components of Joule's law of heating. Working principles of Joule's law of heating. First one is the electric heater. The components made of nichrome. because of it has a high resistance. Nichrome is nothing but nickel plus chromium. Nickel plus chromium plus iron. This is almost 60% of nickel plus 24% of chromium plus 16% of iron. The alloy of nickel, chromium plus iron. This is a chrome. Nichrome is nothing but nichrome is a basic elements of heating elements. Appliances of electric heater is alloy of nickel, chromium, iron. It is a very important property is high specific resistance. What is a high specific resistance? Here, in before section, high specific resistance is directly proportional to temperature. If resistance is increases, specific resistance increases, temperature is also increased. That's why we are using nichrome wire in heating elements. High specific resistance, non-magnetized, easily oxidized, emissivity is a maximum, and is also melting point is also high. High melting point. That's why we are using in nichrome wire. Nichrome is nothing but alloy of nickel, chromium, and iron. So next one is the important role, and specific resistance is directly proportional to temperature. If specific resistance increases, temperature increases first, and second one is high melting point. That's why we are mainly using nichrome wire. Example 2.28, an electric heater of resistance 10 ohm connected to 220 volt power supply is immersed in the water of 1 kilogram. 1 kilogram. How long the electrical heater has to be switched on to increase its temperature from 30 degrees Celsius to 60 degrees Celsius. The specific heat of water is 4200 joule per kilogram. Electric heater of resistance. First of all, write data. Heat resistance R value is equal to 10 ohm connected to 220 volt. V value is 220 volt. Power supply is immersed in the water of mass. Mass of water is equal to 1 kilogram. And how long to electrical heater has to be switched? I want to calculate the time period from increase in temperature 30 degrees Celsius to 60 degrees Celsius, which means change in temperature del T, which is equal to T2 minus T1, which is equal to what is T2 60 degrees Celsius minus 32 degrees Celsius, which is equal to 30 degrees Celsius. Change in temperature is equal to 30 degrees Celsius. I want to calculate the time period, how long to electrical heater has to be switched on. The change in temperature is 30 degrees Celsius. Specific heat of water. You know specific heat in lower section, 11th standard thermodynamics. Specific heat is nothing but amount of heat energy required to raise the temperature of 1 degree Celsius in substance of 1 kilogram of substance. It is called as a specific heat. In specific heat of water is 4200 joule per kilogram. So I want to calculate this time. First of all, R is equal to 10 ohm, V is equal to 220 volt. What is current? Flow of current. This is water heater. The resistance of water heater is R is equal to 10 ohm. Applied voltage is 220 volt. V value 220 volt. The amount of substance, this is immersed in water. Amount of substance is water is 1 kilogram. I want to calculate this current, flow of current. I is equal to, according to Ohm's law, V is equal to IR, I is equal to V divided by R. So V divided by R. What is V value? 220. Divided by R value is 10. So cancel 20 ampere. I is equal to 22 ampere. So I value 22 ampere current flows through the heater. Immersed in water of substance 1 kilogram. So how long the electrical heater has to be switched on to increase the temperature from 30 degrees Celsius to 60 degrees Celsius? First of all, I want to calculate the heat energy per second. Heat energy dissipated from resistor or water heater per second. It is very important. H is equal to H is equal to I square RT. I square RT. So H energy, heat energy dissipated per second, which means 1 second. Heat energy is dissipated, heat energy produced in 1 second. T value is 1 second. So H is equal to divided by T equal to I square R. Plus I value. I value is 22. So 22 whole square into resistance value is 10. Heat energy produced in 1 second. H is equal to 1 second means T is equal to 1 second. So 22 into 22. 44. See 484. 484 into 10, which is equal to 484 into 10 joule. Heat energy released in 1 second, H is 4840 joule. So heat energy 1 second per second, which means 4840 watt. Joule per second is equal to power. So what power value? P is equal to 4.840 kilowatt. Another one value. So no problem. Direct to take the answer. H is equal to 4840 joule. Heat energy produced in 1 second. I want to calculate this total energy. According to thermodynamics, you know well, heat energy produced Q is equal to Ms into del T, specific heat resistance, specific heat capacity. Know well, 11th standard. Heat energy Q is equal to specific heat capacity. S is the specific heat capacity, M is the mass of the substance, del T is the change in temperature in time difference 30 degrees Celsius to 60 degrees Celsius. So I want to calculate this Q value. Q is equal to, what is M value? M value is substance of value is 1 kilogram. So 1 into S value 4200 into del T, change in temperature 30. So Q is equal to 2030. 1, 2, 3. 2, 6, 4, 3s are 12. So 126 joule is the total energy released, produced in water heater. So Q is equal to 126,000 joule, which means Q is equal to 126 kilojoule. This is total energy released. I want to calculate this, how long to electrical heater has to be switched on to increase the temperature from 30 degrees Celsius to 60 degrees Celsius. 30 degrees Celsius to 60 degrees Celsius. So total energy Q is equal to 126 kilojoule. Heat energy produced in 1 second 4840 joule. I want to calculate the time period. You know well, according to thermodynamics, heat energy produced in water heater is equal to heat energy absorbed by the water, which means the law of energy. There is no law of energy based this equation. H is equal to I square RT, which is equal to Q, which is equal to Ms into del T. You know well. So I square RT equal to Ms into del T. I want to calculate this time period. Total, how long to electrical heater has to be switched on to increase temperature. So time value. You know well, T is equal to Ms del T divided by I square R. I square R is nothing but heat energy produced in 1 second. This Ms del T is nothing but the total energy. So time period is equal to, what is the total energy? Which means 12600 joule divided by I square R. Heat energy produced in 1 second. So 4840 joule per second, which is equal to 126,000 joule cancel second divided by 4840 0 cancel. In fourth equation 1 2 1. This is 3. This is 1. Remaining 2 5 0. So T is equal to 31. So T is equal to 3150 divided by 121 seconds. Final answer 26.03 seconds is the time value. Which means how long to electrical heater has to be switched on to increase its temperature from 30 degrees Celsius to 60 degrees Celsius. Time period 26.03 seconds. Okay, students, thank you.